Hi everyone, it's Paddy here from arithmetichub.com, thanking you for choosing this video, but reminding you that whilst this is one method to solve questions like this, it's not the only method. With that being said, let's explore this concept a little bit further. Hi everyone, so today what we're having a look at is converting between improper fractions, Hi everyone, so today what we're having a look at is converting between improper fractions and mixed numbers. So what's important to know when we are having... Let's get it right this time. Hi everyone, so today what we're having a look at is we're converting between improper fractions and mixed numbers. So when we're having a look at these types of methods, what's important to know is what the terminology means, what the key words mean. So we need to know what improper means and what mixed number means. So if you've got a fraction that looks like this, it's called an improper fraction because your numerator is bigger than your denominator. So it means you've got more than a whole. Here we've got 12 fifths. 12 is greater than 5, so it's going to be more than a whole. If it was 3 fifths, it would be less than a whole because 3 is less than 5. But it's because the numerator is greater than the denominator, it's improper, it's more than a whole. You might also have seen mixed numbers that look like this, for example, 1 1/4. Here we have a whole, and here we have our fraction that goes with it. So we've got we've got a whole, and we've got a fraction. It's a mixed number, okay? So again, it's more than one whole. So what we're looking at today is we're looking at converting our improper fractions to mixed numbers. So the method for doing that is over here. The first thing it says we need to do is divide the numerator by the denominator. So again, let's just check we know what those are. The numerator is the number on top of the fraction, denominator is the number at the bottom of the fraction, okay? So when put as simply as possible. So the first thing we need to do is divide the numerator by the denominator. The second thing we need to do, it says whole numbers from the division, they are going to become your wholes. So when we are converting from an improper fraction to a mixed number, any whole numbers from your division, they're going to be what becomes your wholes, okay? Then the third point says any remainders become your numerators and the denominator always stays the same. So in this question, the denominator starts off as 5, the denominator is going to end up as 5. In this question, the denominator starts as 7, so the denominator is going to end up as 7, isn't it? Okay, so let's start off with the first point. Divide the numerator by the denominator, and sometimes when we do methods like this, it's quite nice to be able to set it out like this, where we've got each step, okay? So divide the numerator by the denominator. Our numerator is 12. We're going to divide 12 by 5. Now, one way we can do this is we can write down our 5 times tables if we need to. 5, 10, 15, but we don't really need to. First things first, it's our 5, we probably know those. And secondly, we're only using 2 lots, aren't we? So we would only be going up to there. So we would go 5, 10, 15. We can't go to 15. 15 is greater than 12, so we have to stop at 2 lots. Okay, so 12 divided by 5 is going to be two lots of 5 to stop at 10. And then what we add to 10 to get to 12 is 11, 12. So we're going to add 2 more. So our answer to 12 divided by 5 would be 2, remainder 2. Now let's have a look over here. So the whole numbers from the division, they're going to become your wholes. Okay, so in our mixed number, we are going to have 2 wholes, and then any remainders become your numerators. But we did have a remainder here, didn't we? We had a remainder of 2, so that's going to become our numerator in our mixed number, okay? The denominator, it says, stays the same. So the denominator was 5, so now the denominator is going to stay the same, and it's still going to be 5. So our mixed number is 2 wholes and 2 fifths, or 2 and 2 fifths. Let's have a look at this question then. So, when we're having a look at this question, it says convert 32 over 7 to a mixed number. Again, we're going to follow these steps. So the first step that we need to do is we need to divide the numerator by the denominator. So, what we're going to do is we're going to do 32 divided by 7. And again, if we need to, with our 7s maybe a little bit more challenging, we can write them down. 7, 14, 21, 28, 35. Now I don't need to go further than 35 because I know the number I'm stopping at is going to be 32. So I don't need to write out every one of my 7s. I can just write up to the number where it becomes bigger than the number we're dividing by. Okay, so we've got 7, 14, 21, 28, 35. We know we're going to have to stop at 28 because 35 is bigger than 32. So we've stopped at 28. How many lots of 7 made 28? 1, 2, 3, 4. So we've got 4, and our remainder is what we have to add to 28 to get to 32. 29, 30, 31, 32. So our remainder is going to be 4, isn't it? Okay, so 32 divided by 7 is going to give an answer of 4, remainder 4. Let's have a look at the second part then. The whole numbers from the division become your wholes when you're making it into your mixed number. Whole numbers from this division were 4. Well, was 4, wasn't it? Okay, so our 4 wholes become our 4 in our mixed number. Any remainders become your numerator. So my remainder over here says was 4, wasn't it? Okay, so my other 4 is going to become the numerator. And then the denominator stays the same. The denominator in this question was 7. So if the denominator in the question was 7, then it's going to remain as 7, okay? So now we can see that 32 over 7 as a mixed number would be 4 and 4/7, or 4 wholes and 4/7. Just one last thing for if we're looking at this method. Sometimes you won't have a remainder. So when it says convert 27 over 9 to a mixed number, it might not even be a mixed number. Let's have a little look at this. It doesn't have to be 27 over 9, it's just when you have your answer to your division has no remainders. So let's have a quick look at this one. Divide the numerator by the denominator. So first step that we're going to do, we're going to do 27 as our numerator divided by 9 as our denominator. 27 divided by 9. Again, if I need to, I can write out my 9 times tables. 9, 18, 27. Brilliant. We can see the 27 is in our 9s, can't we? So now what we would do is we would count up how many lots of 9 made 27. 1, 2, 3. 27 divided by 9 is going to be 3. So as a mixed number, it's not actually even going to be a mixed number, is it? Because all it would be is 3 wholes. 27 ninths is the same as 3 wholes. And we could check that, couldn't we? Because what we could do is we could say, right, I'm going to use a method to see if 27 over 9 simplifies to make 3 wholes. So what's the largest number I can divide both 27 and 9 by? Well, I know that 27 is in my 9 times tables, isn't it? So what I can do is I can divide it by 9. 27 divided by 9 is going to give me 3. I've divided the top by 9. I know that 9 is also in my 9 times tables, so now I can do 9 divided by 9, which is going to give me 1. 3 over 1 is the same as 3, or 3 wholes. So our answer would just be 3 wholes. It's not a mixed number, but sometimes that happens with these types of questions.
If you found this video useful, then I would massively appreciate you liking the video and subscribing to the channel. If you want to explore more methods or practice using the method we've looked at here, why not check out the teacher videos at arithmetichub.com. Arithmetic Hub has videos just like this on different methods, specifically targeting areas needed in Key Stage 2. There you can practice one particular skill, or generate your own sets of calculations designed to challenge your understanding of all the topics covered in Years 3 to 6.